Hello and welcome back to a new video. This is the master version of prompt anxiety and the algorithmic politics of uncertainty by David Barry. In a world full of AI automations and prompts, we have to dig really far and further on this type of large language models. And what this paper is going to talk about is exactly about that prompts and what's behind them. This is a paper in which they describe three prompt examples that they did, but also they give us clearer insights about what's going on with the economics and its relation with the subscription model systems, vectors, and so on. This is an enhanced video version of this, but also different because I'm recording this again and will have probably different insights and commentaries from my end. This is a channel in which the main purpose is to come this information to the light about papers, articles, documents that are burdened into a bunch of Google search web pages. It is not uncommon that the papers and the articles are not mostly widely being written right now by most of the population out there. Now we're focusing more on social media and we are leaving those behind outside of the academic world. So let's give light to the information that can matter and of course for us to be up and aware of the current situation between the technological world. Welcome back. We are going to start talking about Walter Benjamin, and he had very different points of view where he made a correlation between the bidding system or the gambler type of mindset between the AI prompts and how we structured them. He identified in the gambling halls in the early 20th century finds unexpected resonance in today's computational interfaces. The rise of prompt engineering as a new technical practice shapes now the output of large language models, and the abbreviation will be LLMs from now on. This reveals an engagement with probability and chance that it can be claimed mirrors the temporal and psychological structures that Benjamin identified in his Arcades project. In Benjamin's short fragment, Note on a Theory of Gambling, he describes a figure that I will be exploring and that this author explores of particular relevance for this computational moment. But what about the gambler? A critique of the gambler is as much a way to honor the dream which harbor in aleatory experiences to decipher its historical shape. It is an attempt to do justice to a structure of desire that is itself produced by a structure of power and possibility. So people are taking advantage based of those two. Benjamin's position is refreshingly ambivalent. The allegory of the gambler is an indication of ideology and insurgency. We also have revolutionary vitality, a conservative desire to keep the present order, as is and the radical urge for its undoing. It is both at once. Benjamin's also exhibits a particular psychological structure. The gambler operates through what Benjamin terms purely reflective moves, rather than a calculated strategy. Each wager that is made represents an immediate response to the demands of the moment rather than part of a coherent plan extended across time. This means that the gambler experiences time as a personal perpetual present rather than as progressive sequence. You focus on the now, on quick gaining and reward instead of focusing on long-term achievements and goals. Each throw of the dice can be understood as undermining historical continuity, creating a pretty effect that can be addictive, where the past losses and future consequences collapse into the immediacy of the current bet, the immediate reward. This creates a temporal structure that generates a specific affective state in which the gambler swings between hope and dread, between the fantasy of total redemption and the reality of mounting loss. Eventually, Benjamin argues this psychological oscillation that becomes something progressive, even as we mentioned before, addictive, because it offers escape from the progressive temporality of capitalist accumulation whilst remaining thoroughly captured by it. Let's have this fantasy, this picture that if you go put your money into a machine, then you might have something that could solve all your problems, desires in just one single dice. That could be really powerful or really damaging on your brain. But the psychological structure finds an interesting analogy to current prompt engineering practices. Users of LLM systems similarly operate through reflexive adjustments rather than systematic planning, for example, in so-called bytecoding. The stochastic nature of these systems has a reliance on what we can call prompt salting, which transforms each interaction into an immediate wager, whose outcome cannot be reliably predicted from prior experience. This makes the production of outputs less a science than a product of chance. Users of systems like ChatGPT, Claude, Stable Diffusion, and even open weights models find themselves having to develop elaborate strategies for maximizing desired outputs whilst acknowledging the unpredictability of generative artificial intelligence. These strategies could, therefore, be said to exhibit the same mixture of systematic analysis and aleatory hope that Benjamin argues about gambling psychology, creating a kind of replacement to rational design processes or software engineering and replacing it with practices mentioned above, like bytecoding and effective coding practice that manifests as a kind of computational gaming culture organized around the optimization of prompts against probabilistic system. But what about prompt salting and this type of term? We use it to refer to the automatic injection of probabilistic variance into large language model outputs through what are called stochastic sampling techniques. And as we continue, this transformation of technical practice into aleatory experience generates what it can be called prompt anxiety. Prompt anxiety describes the psychological state produced when users must maintain a fiction of systematic control whilst confronting the irreducible unpredictability of stochastic outputs. Unlike conventional technological frustration, reliable results and prompt anxiety emerges from the recognition that no amount of expertise can eliminate the aleatory dimension of LLM interaction. The user experiences each prompt as a bet, where even careful preparation offers no guarantee of required outcomes. This creates a distinctive, affective state characterized by an obsessive attention to textual details, such as a word choice, syntax, formatting, or tone, but whose actually influence remains unclear. So imagine if you're really a perfectionist, this can be something that could set you off. And it could give you more trouble than you might have thought. It also produces a tendency towards compulsive iteration through multiple attempts despite diminishing returns from the prompts and what we could call interpretative paranoia that assigns systematic patterns to what it actually may be random variation from the system. Prompt anxiety thus represents a structural feature of how stochastic systems, particularly those used by platform companies, increasingly organize cognitive labor. This prompt anxiety signals a broader shift in the organization of cognitive labor that recalls Benjamin's analysis of modernity's relationship to chance and temporal disruption. Haven't you sat down in front of your computer and want this artificial intelligence to solve all your problems, all your workload, just in single prompts? Is it that normal? Is it not? Or is that the new quotidianity that we need to get used to? To see this computational gambling psychology in practice, it is useful to examine the production of probabilistic media, that is, cultural or media artifacts produced through stochastic computational processes that operate on probability distributions rather than deterministic rules. These forms of media are increasingly flooding the internet and social media and serve as a useful example of generative processes in media production, although they are often despairingly called AI slop. For you, what is a slop? The analysis developing here combines critical theoretical argument with early empirical experimentation, drawing on Benjamin's critical theory alongside original computational analysis of large language models. And we also have that the model calculates probability distributions for potential net tokens, because we're going to talk about tokens for sure. Then uses sampling parameters to introduce control randomness in token selection. And that randomness can be also into the loop of the gambling type of mindset. This auto geographic structure of some LLMs means that early random choices compound throughout the sequence, amplifying the effects of probabilistic sampling and ensuring that identical prompts can produce dramatically different outputs across runs. And that is what this paper is for. The term salting, taken from cryptography, is useful as it captures how this randomness can be the output in ways, or can describe the output in ways that enhance variety but resist precise control, and can be understood as similar to how cooking salt transforms ingredients in somewhat unpredictable ways depending on its use and the quantity added. And I love that example. By vector, we can say in which information is stored within vectors. And then we have the vector space into this is going to be the area in which these vectors are going to be stored. This gives the models their power to generate new token arrangements in text or in new forms of synthetic media generation. Examining Benjamin's notion of the gambler can be useful for thinking about artificial intelligence and the specific models of consciousness that appears to evoke. We also might be looking at the features of large language models that seem to reflect the commodification of chance through the extraction of value from commons and social relations rather than direct wage labor and economics and related topics. Looking at the collective interpretations from users, we'll be also be doing some echoing this information that I'm going to be disclosing to you. We have so many questions and hidden transcripts that probably we might be also looking forward to each one of us to see what are we doing, what is hidden behind these large language models and the current platforms that we're using nowadays. We cannot escape these LLM systems anymore. Users must similarly write prompts within the constrained interface of text boxes or parameter settings, making decisions about keywords, syntax, and formatting that will trigger the probabilistic generation process of synthetic media. And we do this almost every single day, even if we don't want to. Even in our job, can be using AI. So we cannot escape it anymore. Like Benjamin's gambler who places bets at very last moment, the moment moreover when only enough room remains for a purely reflexive move. Prompt engineers operate within temporal constraints that compress deliberation. The same button functions rather like the dice throw, a moment of commitment that transforms careful preparation into an aleatory outcome. Like Benjamin's gambler, the temporal dimension reveals itself in the psychological forms that prompt engineering individuates. We also have the AI behavior, analysis of how prompt marketplaces commodify uncertainty, an investigation of the labor conditions under which professional prompt engineers operate. It is suggested that more detailed empirical work could usefully inform and test the approaches suggested on this information. So we need more people talking about this, but also investigating about. The prompt engineering community's development of magical thinking around AI behavior recalls the Saint Monday traditions through which industrial workers asserted alternative temporal rhythms against factory discipline. All the culture of resistance that Willis identified among working class youth. Saint Monday was a day that was traditionally taken off by craft workers as a day of recuperation, often without the agreement of employers of manager. We had different examples in history about introducing new forms of advancements or shown as advancement, but of course, we have a current society that sometimes can be agreed upon that, follow upon those new ideals, and perhaps not. But let's continue talking about this important topic. Benjamin's concept of uncertainty draws upon Hegel's dialectical understanding of contingency, where contingency functions as the mediating term between possibility and necessity. What becomes actual under specific conditions could always have been otherwise. Marx transformed this Hegelian insight, this insight about Hegel, by situating contingency within capitalist accumulation itself, arguing that apparently random events become systematically organized to create conditions for value extraction. Contemporary AI platforms similarly transform uncertainty from technical limitation into an extractive mode. Capitalist social relations thereby appear as natural properties of objects themselves rather than the social relations that create them. The importance to keep in mind the dialectic of disguise and surveillance that we have between the relationship of LLM and the user, it is important. These systems often hide behind a psychophantic persona that is nonetheless capturing data and surveilling its human conversation patterns. Indeed, we might know that the performance of difference and consent while attempting to discern to read the real intentions and mood of the user is a tactic of current LLM user interface design. And yes, we honestly we don't tend to read those. But what about the rest? The prompt engineer's relationship to algorithmic uncertainty reproduces the classical structure of commodity fetishism, where human social cooperation appears as autonomous technological power. Yet, unlike Marx's industrial commodities, AI systems reintroduce uncertainty into this fetishistic process, creating fissures through which the social character of algorithmic production becomes inadvertently visible. Traditionally, the temporal compression of LLMs is an important part of the experience of prompt anxiety. It is argued, therefore, that a distinctive psychological aspect where users experience each output from the large language model as a wager against unknown algorithmic possibilities. Consequently, we see online forums dedicated to prompt engineering, which often reveal users developing obsessive strategies for controlling outputs that remain uncontrollable. For example, this can be observed in the elaborate prompt libraries that have emerged around LLM generation, featuring thousands of testing combinations designed to produce particular aesthetic effects. These libraries can be seen as similar to gambling systems, promising users greater control over outcomes with acknowledging that no prompt can guarantee specific results. The psychological mechanisms underlying these practices might therefore reveal deeper structural parallels with gambling behavior. What is interesting is that this psychological aspect of prompt engineering exhibits what one author identified in political discourse as a paranoid style. This is a tendency towards elaborate interpretative schemes designed to explain apparently random outcomes through hidden systematically patterns. And if you want to see more about it, you have to go back to Hofstadter in 1966. Users of AI tend to develop complex theories about hidden biases in training data, prompt injection techniques, and model alignment issues that supposedly explain why their carefully crafted prompts produce unexpected outputs. These theories perhaps serve a similar psychological function to gambling superstitions, providing the illusion of systematic control over processes that remain stochastic. This paranoid interpretative tendency, in part due to the contingency of the output of these systems, finds material reinforcement in the design of LLM systems themselves. But it is crucial to remember that this contingency is not neutral. Indeed, it always occurs within specific social relations that can be analyzed, contested, and potentially transformed through collective practice. It is argued that the technical architecture of these systems actively encourages a paranoid style through what developers call prompt sensitivity. Prompt sensitivity describes how minor alterations in input can produce dramatically different outputs. In practice, prompt engineers have developed an elaborate repertoire of techniques to manage this sensitivity. These include chain of thought prompting, where the user instructs the model to think step by step before answering, forcing a more structured reasoning process. Through the role playing instructions, where the user assigns the model a persona to constrain its register and domain, whereas for media directive that specify output structure through markdown headers, bullet points, or number lists, and temperature manipulation, where users who have access to this parameter lower it towards zero to reduce stochastic variation or raise it to encourage more creative output. For example, the persona could be now you're a math expert with 10 years of experience on your prompt, or you can say you are a great musician and you're going to compose the following piece with these instructions. Each of these techniques represents an attempt to impose a kind of deterministic control over a probabilistic process. Yet, this cannot completely eliminate the underlying stochasticity. Even with careful prompt construction, the same input can produce substantially different outputs across runs. This sensitivity creates what users experience as prompt paranoia, where every word choice becomes fraught with potential consequences that cannot be predicted in advance. Users therefore begin to develop elaborate techniques for prompt debugging by testing multiple variations to identify which elements produce desired effects, creating a form of systematic superstition around text manipulation. Thoughts configure the computational interface becomes a site where magical thinking emerges, representing a return to pre-modern epistemologies within ostensibly rational technological systems, where correlation becomes causation and pattern recognition becomes predictive power. This return to magical thinking within computational systems reveals how deeply the gambler psychology has went through our technological interactions, where systematic analysis give way to superstitious practice. Here, the computational and the ludic meet, revealing how LLM interaction shares the gambler's relationship to chance, calculation, and temporal compression. Much of what these prompt engineering communities have learned through binocular experiment has since been empirically investigated by the model developers themselves. But what about LLM Bench, a web-based tool for the comparative close reading of the LLM outputs that enables researchers to subject AI-generated texts that was developed by David to hermeneutic close reading purposes. LLM Bench includes a token probability visualization mode that makes the aleatory dimension of text generation directly observable. This will be able to send the same prompt to two different large language models, Google's Gemini 2.0 Flash and OpenAI's GPT-4o, and examine the probability distributions underlying their outputs. Now, for the prompt scenarios and the samples. In this case, the prompt asks each model to explain how Polanyi's concept of the double movement applies to the development of artificial intelligence. Both models therefore received identical prompts from which they generated their prompt. The results make the structure of prompt anxiety empirically observable. What we can say about the outputs of this experiment might be the following, showing that the picture that Benjamin gives about the gambler represents a figure of temporal experience and a transitional form of labor subjectivity. The gambler suspended temporally therefore anticipates the contemporary prompt engineer's relationship to algorithmic uncertainty. Yet where Benjamin's analysis remained focused on individual psychological structure, we can begin to see how gambling psychology becomes embedded in the social organization of production itself. For example, through Karpathy's notion of software 3.0, which is created through contingent generative looping and verifying of the output of the LLMs. Understanding prompt engineering within these longer trajectories of automation also helpfully reminds us of the importance of continuity and rupture with earlier forms of industrial organization. For this, production thought to eliminate uncertainty through standardization, extracting workers' knowledge and delegated it into machine systems designed to minimize variability. Yet, even within automated factories, chance never disappear entirely. Machine operators developed embodied skills for responding the unexpected material variations that could not be fully programmed away. Contemporary algorithmic management represents a further qualitative transformation of this trajectory. Like for these systems, AI platforms extract and codify human knowledge, while unlike their industrial predecessors, they reintroduce this knowledge in a stochastic form. The prompt sorting processes characteristics of LLMs represents a summary of standardization and unpredictability. These systems simultaneously encode knowledge whilst generating outputs through probabilistic sampling that cannot be predicted in advance. Wherefore, this production sought to eliminate the worker's subjective relationship to the production process. Algorithmic systems depend upon cultivating new subjectivities organized around interpreting and managing computational uncertainty. The prompt engineer's labor represents the emergence of a skilled interpretive work within highly automated systems organized around stochastic temporality, rather than the repetition of standardized procedures. Thus, the algorithmic systems that produce prompt anxiety is not a complete break with industrial modernity, but what Gramsci called the passive revolution. This is a transformation of productive techniques within continued relations of domination. This author argues that the corporations maintain dominance through economic control and through what he called transformism, that is, the capacity to absorb and neutralize potential oppositional forces by incorporating them into system structures of power. Indeed, contemporary AI platforms often practice this form of technological transformism, converting user resistance and collective innovation into sources of value extraction whilst maintaining the appearance of technological neutrality. To understand how this is produced and also used, we must examine the material conditions through which AI platforms transform uncertainty into extractable value. Indeed, the arcades that Benjamin analyzed as a space of individual chance encounters have developed into computational platforms that now industrialize the production of aleatory experience. In other words, contemporary AI platforms have systematically transformed the gambling psychology and was identified into a source of value extraction that represents an intensification of capitalism's systematic transformation of uncertainty into value. Now, would you like to know more about this and other topics? Let me know what are your thoughts until this chapter, because we're going to continue and with dark patterns. Dark patterns in vectors, dark patterns in subscription models on the AI systems, and more. So let me know your thoughts. See you in another video.